Yeah. So we come to the 3 months of monsoon are over. We're pretty much it's like the 15th over of a T20 match. It's all over. Okay. It's not going to be no chance. And the reason is very simple. I just took what I said that today also pretty low. 627 is yesterday. Today it will be 630. Tomorrow, last day of August, it will be 634. That's all. Okay. So if the monsoon has to be normal, it has to rain 220 millimeters in September. That is a very rare event. It happened. It happened in 2019. Not going to happen every year. And it is a theory of El Nino. Okay. Second thing is, IMD said it will be 90, maybe as low as 94% of the normal. For that, of course, 170 millimeter will do the job. So either the September rainfall has been normal or above normal. Okay. Both don't look good because we have El Nino going, and I'll show you why this. Now, what's interesting about the monsoon co-region is this is the longest break in August in the last 150 years. Okay, that's amazing, and even now nobody has understanding why. Okay, the funny part today is remember the GFS forecast 10 days that is quite good. It did predict the break, but if you ask why, we don't have an answer. It bothers me that we have looked at, people have looked at here and other places, the 1979 August also has a very long drought, 15 days, this is 22 days. Even for that, I don't see any answer so far. I've not seen a paper which says why the drought, the break was so long. Okay? Even for that, we don't have an answer yet. So this is a important issue. And if you look at the SSK anomalies, we still have some unusual anomalies here, extremely large, 5 degrees. Okay. And if you go by Arindam's technique he adopted for June, July, not August, this has some impact on the Indian rainfall. Am I right, Arindam? Yeah. But the question is, it has the impact in July, but not in August. So this year's most interesting thing is, why was July normal and why was August so bad when the SST has not changed much? We look at the SST anomalies in July and August. There is a slight difference here. It increased a little bit in August compared to July. Otherwise, everything else was same. Okay? So if you believe in boundary condition driving the monsoon and circulation, boundary condition was not very different. So I don't have an answer why. In 2 adjacent months, both things. See, what is that? All of us talk about JJS. June is the onset phase. We had lots of problems. Cyclone came. Okay. Then September is the withdrawal phase. That can be other. So normally we focus on July and August, supposedly the peak of the monsoon. And we expect to behave similarly, but they don't. And I'm not seen anybody answer that question. Why in some years, July and August behave differently, although we are on the essentially in the peak phase of the El Nino, it's not changing much, it's actually even increasing further. So this is the biggest puzzle of this year. Okay, to make my part clear, I've done about half an hour back. There may be a mistake, you can check it. This is, I am correlating rainfall over India with SST everywhere. Okay, just to see what are the places which are you can see in July, I'm sorry. I'm doing month of month. People want to do JJS, okay, so that the correlation goes up. But I think we should look at monthly. And in July, you can see that yes, there is a role of El Nino region. Also, the role of this region. Look at this. They're not small. They're 0.3 or more. Okay. So I believe this year, this partly computed this. Okay. Now, this is not a cause. This is an effect. The large cooling over India is purely consequence of above normal rainfall. There's more wind. It cools. So this is not something one can do for explanation. This is the remote role. And you see in July, these two are not comparable, but this can counteract this. But here, come to August. I can't believe it. I thought there's a mistake. I did again. I didn't find a mistake, but you can check it. There may be some problem with the data. There is no correlation. I'm not seeing anyone say that. In August, 3.4 has nothing to do with Indian monsoon rainfall. I mean, I've never heard anybody say that. I'd like you to verify it. So this to me surprised me. And this partly explains why this difference played a role this year. Okay, we'll come to that. Okay, now the other thing, because I'm obsessed with July 2002, I'm still not forgotten that, because I not explained it well. So I looked at the circulation anomaly, that is maternal bend anomaly at 2-foot value bar in August 23 this year and July 02. Okay, look at the big picture; they are very similar. So I found a common factor. Circulation anomaly. The answer is no. This happens whenever you are a large major drought in any month in the monsoon, the mid-latitude system move into India. Okay, this is not a cause, this is the effect. Okay, this is a very common problem in our monsoon research. People confuse cause and effect because they keep doing correlation. Correlation doesn't do anything. Correlation proves association, doesn't prove anything. Okay, so this is very nice result. I did some work many years ago also. It leads nowhere because if you take monthly mean, you can get nothing out of this because everything has already got adjusted. Okay, but this is interesting that August of this year and July 2002 are very similar, both in the southern hemisphere and the northern hemisphere. Note that in both of them they show a similar structure. This part I still don't understand. This, I think there's something there. I looked at many times, but so far the impact of southern hemisphere and Indian monsoon is still not clear. Very few people have looked at it. Okay. Then you have this paper, recent paper, on the tropical mid-latitude pelican. As a matter of fact, whenever you have puzzle in our field, like 1979 and 2002 and this year, they will say it's mid-latitude interaction. Very simple excuse to give. This excuse going on for the last 60 years, I tell you that. Okay. Now, for example, this paper says uses a very modern method called network theory. I don't know how many of you have looked at it. It's a new method. But just with correlation, they look at various points in the globe and connect each other. Okay? I don't fully understand what they have done, but the image I like very much. They say one standard deviation change in circumglobal teleconnection, which is the teleconnection you see here around in middle latitude, starting from just here. There's a clear connection all around, goes around. This is what Big Mom found about 15-20 years ago, and they have seen the connection is that and in the summer monsoon. But no, notice, first time I see people quantitative data, which I like. They say one standard deviation change in the teleconnection causes 0.2 standard deviation change in ISMR. Okay? Straight away I lost interest. Because this year deviation was more than 1 standard deviation. Okay, because now right now August is minus 40%. Okay, a record. And July 2002 was 50%. So this won't explain. It may still explain minor fluctuations that we see interseasonally, but not a large fluctuation. Okay. But it's a good paper, please read it. And it's a new technique. I'm too old to learn it. Some of you can learn it and use it. Okay. Okay, then most interesting point about this is the typhoon. This year, there were 2 major typhoons in West Pacific, and in July and 4 in August. Okay. So the number of typhoons were more in August, and the duration was also given here. Here about 11 days, here about 23, 26, 28 days of typhoon. Okay. So last time, Sulasa made a point that the typhoon may be affecting the Indian monsoon. Yes, possible for a few days, yes. But one typhoon cannot determine the monthly mean. But if you have 4 typhoons, all of them lasting 1 week and so on, then it's possible. Okay. Now here again, there's a big confusion going back to again 60 years. People have said that there are more typhoons in Pacific. Indian monsoon is weak. Actually, the truth is the other way around. When the Indian monsoon is weak, typhoons strengthen in the Pacific Ocean. Okay. Again, association and is confused with cause and effect. And but I'm not anybody really. Somebody can do modeling, can somehow see whether putting a heat source in the West Pacific between 10 knots, 40 knots, simulating a typhoon for a month, doesn't affect the monsoon. It might. A lot of people have looked at that issue. No, okay. Yeah. So I want to show you what's happening. There's a very important new issue coming up due to climate change. Now, the last 1 year, actually this year, there were two long-lived cyclones which broke all records. This is one of them. It started in South America, went all the way to polar region. Okay. Now in February, there was one cyclone which went below India, you didn't see it, went to Indonesia, to Africa and back. And that one lasted 1 month, which is the all-time record. Okay. So this is the consequence of global warming. When the global mean temperature has gone to 1.2, there are parts of the ocean have gone much more, and the cyclone is able to get energy and keep continuing as long as it is on the ocean. It hits land, of course, all over. So both in the Pacific and Indian Ocean, Southern Indian Ocean, we will get more and more cyclones which will go for longer distance. Okay. Yeah, and then the most recent one, last week of August, is this Saola, which really came somewhere in the air and then went on a night loop and then still and went and hit, I think, Taiwan and China. So all these had some impact on our August rainfall, but we don't know the connection, which is first and which is later is not understood. Okay, so there's some details about, you can look at how many days, for example, the number of hurricane days is double the normal value. Normally it was 9, this August was 18 almost. Okay, now let's look at some other issues about which normally not discussed. See, normally a lot of us, based on Gil's idea, we wonder whether the 3.4, the heat source increases in that region and that causes some change. But very few people, I have not seen any paper, very few look at the vertical structure of the heating. Now, they should have done that because we all know basic understanding of tropical system, where the heating maximizes, controls the circulation effect. If the heating is very low, it's a one-time impact. Yeah, I have not seen a single paper. Again, I'm putting this out because if any of you see, please let me know, I'll look at it. I've seen lots of papers shifting the heat source all the way from 120 east to 180 east, nice papers, but that heat source is standard maximizing at 500 millibar. But when you look at year-to-year variation, there are differences. Some years it maximizes load higher. So here this year, omega anomaly, okay, whole structure, and this is the month of, this is 120 to 180, this is the month of July. Okay, just keep this in mind. I'll show you August. August is very different. Okay, because the typhoon, lots of typhoons, not one typhoon, it has shifted north of the equator compared to July. So to me, that is the clear point. In July, the heating was confined to the equator. In August, it was the equator as well as off equator. Okay, then let's see my favorite velocity potential anomaly. Now I want you, this again, preliminary work, there could be some problems. I compared what happened on 30th July and 2nd August. Okay, I'm sorry, below you. The 2nd August, 30th July, and you see a big difference. In 30th July, this upper level convergence here, or Madagascar, shifted in 2 days to just south of India. And that seems to be linked to the upper level convergence here. Okay, this is not a proof, it's just an association. Okay? And because the entire thing has slightly shifted to the east, this southern hemisphere Rossby way. Okay? And I believe this is the transition to break. I knew that, but this is still a work under progress. I will not claim it is true. Now, what happened? Mean of August till 20, can see that this became much higher upper lower convergence than here, and this was the one which caused a long break. But this has been examined. But this is, there is no evidence. I looked at all other data. There is no connection I can see, but this connection is interesting. Also, I'm saying this because I remember that in July 2002 also such a correction was seen, but the work was not completed, unfortunately. Okay, now let's go back to the hope that something better will happen in September. The hope is, of course, IOD. IOD has been a great hope for Indian monsoon, but this year I doubt it because look at this. This year there is evidence of SST going down, but nowhere near the equator. It is well south of the equator, around 10 south. It may develop, it may go this far, but going by the short-term forecast of GF, it may happen after 15th September. By that time it may be too late to really make September well above normal. So if they really develop further all the way here, yes, IOD may play a role, and you may have a normal September. That is, the IOD counteracting the role of El Nino. But if it is delayed by a week or two, Nothing will happen. Okay, keep that in mind. Now, what is this? This is, I want you to show September. September, I have compared the El Nino 3.4 correlation with OLA. Instead of rainfall, OLA is more. You can see clearly in September, it's a very high correlation, 0.7, okay, over India. The OLA in India increases in response to El Nino 3.4. Amount is around 0.7, which you don't see in any other month. You look at June, you look at July, nothing. September dominates. I don't know why. Okay, so this again is related to the mean circulation in that month. So somehow September allows you to link this upper level flow to this descent over there. Okay, seems to okay. And notice that these two are connected, Indonesia and India, both. You will see that. You will see more and more descent over Indonesia and also India. Okay, now let's look at the news from GFS. Not good. Till about September 9th, we're going to have a normal rain. Okay. So if September has been normal, the second half of summer has to make up in a big way. I don't see it happening. Okay, I hope it will happen, but because you know that there's a distress both in Karnataka as well as Tamil Nadu as well as all India. To me, such a long break in August will have a huge impact on agriculture, and the prices will go up. And there are elections coming up. Everybody is nervous, so you will see a lot of impact of this monsoon in politics. Okay. Now let's look at the 14-day forecast, which I've been looking at during the whole period, and you can see clearly this year, because of the El Nino, there's an early withdrawal of monsoon. Clearly, okay? Two different models are telling you that North India will get very less rain in September. South India will benefit somewhat. Then next, as a matter of fact, starting today, tomorrow, rain will start. It was missing in Bangalore and it's getting very hot now, relatively, of course. So you'll see the change, and you'll see a lot of rain in South India in September, but it cannot make up for such a huge negative anomaly, 30–40% anomaly in North India. Okay. Now let me just summarize. So I'll be showing this all the time because this is the period of our discussion. So 115 in June, 316 in July. That's what helped us. It's going around 165 or maybe a little bit more in August, and I'm guessing 120 in September. We add it up, we get 752. Okay. That'll be one of the lowest comparable to 2015. The only difference in 2015 and this year is the fact that in 2015, July was not so good. 15 was normal, but August also was below normal. But June was a little high. Somehow I don't know. It's okay. Overall, it comes out same almost. So my prediction is this year's rainfall will be comparable to 2015. And the reason I'm saying this is in 2015, IMD correctly predicted a drought. Okay. This year, I don't know why they did that. We don't know the detailed experiment inside that IMD. They put normal, but I think they'll most probably get this. But there is still one more month. We'll see what happens. Now I want to compare. I want to just introduce the idea. I'll talk about it later subsequently. I compared rainfall over India with rainfall everywhere. Okay, just to see the connection. Okay? Forgetting 3.4. And what you see in the month of August is a clear dipole structure between China and India. Okay. Now this is not there in July. Now this is surprising to me. I've not seen that before. When this time I've seen it, but this is July. July, there is a Northeast and West India dipole, which we all know that, the standard, but not here. So to me, that's the crux of the problem. Whether 3.4 affects India or not depends upon local interaction between China and India. Okay, people in the drought